Hi, welcome to the Vector Forum. My name is John Krzeszewski, and I am a cybersecurity architect at Eaton Corporation. Today, I'd like to talk to you about leveraging DevSecOps to help optimize your software development and also to enhance cybersecurity for your applications and systems. So first, I would like to go through the agenda. I'll do an introduction of myself, and then we'll talk about DevSecOps and how did we get to DevSecOps, and then why is it beneficial to use DevSecOps. Then we'll talk about points of resistance that you may encounter if you're not already using DevSecOps, and then we'll talk about the lifecycle, workflows and principles of it, associated tools, and those activities that are related to it. And then we'll summarize at the end with what are some best practices for DevSecOps. So first of all, I want to talk about Eaton Corporation. Eaton Corporation is, been around since 1911. We work to make a positive impact on the world by giving people the tools that they use, to use power more efficiently, and to help companies just simply do business more sustainably. And we also encourage every Eaton employee to think differently about our business, our communities, and how we can help create a better future. At Eaton, we're dedicated to improving the quality of life and the environment with sustainable power management technologies that are more reliable, efficient, and safe. With the rapid growth of electrification and energy transition driven by explosive growth in connectivity, we think we're well positioned to solve some of the world's toughest electrical, hydraulic, mechanical, power management challenges, because that's what really matters. And we're here to make sure it works. So I'd like to talk about Eaton's cybersecurity. First of all, we're dedicated to establishing cybersecure processes and innovating technologies that make trusted connections work. We're in a hyper-connected world. Trusted environments are a must. Eaton's commitment to defending these environments comes to life at our product Cybersecurity Center of Excellence, of which I am a member, where our group of experts discover new ways to help protect products and systems against cyber attacks. We also provide internal training and helping customers deploy and maintain secure solutions. In many companies, cybersecurity, unfortunately, is an afterthought, making evident by the number of updates that are being deployed to account for process miscues. But at Eaton, cybersecurity is part of our DNA and integral consideration with strict protocols on the people, processes, and technologies within our secure development lifecycle. The program that integrates security protocols at every phase of product creation. The SDLC spans from inception to maintenance, to including design, of course, and including enforcing those best practices that are critical via training, threat modeling, etc. And our cybersecurity practices, they extend beyond our labs to help keep our customers informed about potential vulnerabilities and provide customer insights, as well as tools and other educational content. So it's very important to make sure that we have secure products, and Eaton is very proud that we are the industry first to have our processes, procedures, and people certified under two independent certifications, both UL 2900 and IEC 62443. So let's talk about, first of all, introducing myself. Like to let you know that I have been a member of the ISO SAE 21434 Joint Working Group. I'm currently an architect for cybersecurity within our product Cybersecurity Center of Excellence. I've also been a chair of the ISO SAE 21434, specifically the section on threat analysis and risk assessment. I am currently chair of the SAE Vehicle Cybersecurity Systems Engineering Committee, and also co-convener with ISO on subsequent automotive cybersecurity related standards development. So on to our presentation. So let's talk about what is DevSecOps. Well, I like this definition that comes from the DoD, and simply put, it's a best practice for making sure that you have secure software development, but it's done in a rapid manner. So, as it indicates, it's an organizational cultural shift for software engineering that unifies the development, security, and operations collectively together. And the one of the main characteristics, as indicated, is to automate, but also not only automate, monitor, and apply security at all phases of the software lifecycle. And we'll talk more about that in subsequent slides. So testing and security are shifted left, and we'll talk more about that, explain what that is, through automated unit, functional integration, and security testing. So one of the advantages, it gives you faster and more secure software with consistent governance and control, which is vital. Well, how did we get here? So if you look at this development over, I'd say, the last 30 years, 30 years ago, for those of us that have been around for 30 years, back then we were doing waterfall development, and we remember that it's a very slow process. We'll cover this in more detail. Typically developing monolithic applications on physical servers. And communication protocols were proprietary. We leveraged things like firewalls for protecting things. And the life cycle was in terms of years, maybe months, but it was a long development process. Then 15 years ago, we moved to Agile. So now we're down to months or weeks. We're getting improved using agile processes, changed our architecture to now more an N-tier type of architecture, leveraging virtual machines and data centers, and starting to use standardized formats like XML, but we're still in the months or weeks. So with the present day DevSecOps, well, now our releases are in weeks or sometimes even days. And we're doing things like microservices, leveraging containers in the cloud, standardized formats like JSON, and leveraging technologies or philosophies such as zero trust to enhance security. So we can see the evolution of how we got to DevSecOps. So why don't we use waterfall anymore? Well, there's several disadvantages. As a reminder, there's the concept phase, the new requirements in architecture, new design and implementation, and then secondarily at the end of it is when you do your testing. So because of that, because of the nature of the long V cycle, it doesn't support changes. So if the customer wants something different, or you discover something in testing, well, it takes quite a while to adjust to that change and to make the associated fixes or changes as being requested by the customer. So, discover defects. If you discover them, it's very difficult to address because often the developers are maybe off doing something different, maybe a completely different project, because they're done with this development, they're off to a different project. And it was discovered a long time after it was developed. So results in things like slow delivery and late feedback from customers. You're getting late end user feedback, but that feedback is critical. So, of course, we did do risk assessment throughout, but nonetheless, the V cycle is definitely the old way of doing things. So what I'd like to say, in the United States, they had a saying in the 1800s, go west, young man, go west, which simply means, the west of the United States was opening up, and it was encouraged that's where opportunities were. So as a play on words, I'm saying go left, young man, go left. What does that mean is the benefit of DevSecOps is shifting left. So what does that mean? It simply means testing earlier and more often and throughout development. And why is this important? Because as you discover defects, the earlier you discover those defects, as seen in this data here on several studies, the cost to fix a defect rises dramatically the later you discover it. So, for example, an IBM study shows that after launch, it can be up to 100 times more costly to fix a defect than if you had discovered it during validation itself, or better yet, during development, or better yet, during design. And the more that you shift left, the more that you find those defects, the earlier, the quicker it is, and the less amount of time. It takes a lot less time to remediate those vulnerabilities. But so it's important that you do that remediation throughout the life cycle. So what are some benefits? Well, there's quite a few benefits. Some of them we talked about, but reduced mean time to production. So how long does it take between when you're conceptualizing a new feature and when it gets released to production? Dramatic reduction. And how often you're able to deploy, because DevSecOps, the key thing is you are breaking a larger problem into, or a larger task into, a lot of smaller tasks. So you implement a feature, test it, release it. Implement a feature, test it, release it. So the customer gets to be able to use it faster and earlier. So you have an increased deployment frequency. You're not trying to get everything done. You release a feature with development, testing, and release. So you're deploying potentially up to 30 times faster, according to the studies indicated below. And when there is a problem after you deploy, because of the methodology of DevSecOps, the amount of time it takes to recover is dramatically reduced. But even better yet, the amount of failures you get when you do release something in operations is also reduced significantly because of DevSecOps. You're finding these defects earlier, better collaboration. And the fact that you're automating risk management. So you're characterizing risk, whether it's project risk, or I'd like to talk about cybersecurity risk is kind of my focus as a cybersecurity architect, but you're monitoring and mitigating that risk constantly throughout rather than late in the life cycle. So cybersecurity, well, it's baked in. It's not like, okay, let's add it at the end. It's continually assessed. And because you're continually assessing, you can make those changes quickly. And it breaks down walls and allows teams to collaborate more closely. I remember when I was at a medical company, I would develop a package that would be deployed in production. I had to create the package, create all the documentation, and basically throw it over the wall, if you will, to our IT department for them to install. And occasionally there were problems, or maybe something wasn't clear to them. It's because it's that disjointed development. You're not working collaboratively as a team. You're sort of throwing it over the wall. And so here you're breaking down those walls. You're hyper collaborating with teams. So it's a culture change also, and it results in less problems and less friction in teams, yielding tremendous benefits. So if you're a Star Trek fan, you may remember the phrase "resistance is futile." Well, the thought is here: you're gonna get pushback if your organization is not already leveraging DevSecOps. You're probably going to get some pushback, and you need to expect that. But there's perception and reality. So the perception is, I don't know what DevSecOps is. Some people really don't understand what DevSecOps is. It's quite simple. We've kind of talked about it already, and we'll go into more detail later on. But that's it. They don't understand it. They think it's maybe more complex than what it is. And they may not perceive the value of it. Hey, we've always done it this way for years. It works. We've heard that a lot. We've done it this way for years. It works. So the reality is, yeah, it may be working, but you're going to get increased customer satisfaction. You're going to be able to make releases quicker, improve security. Tremendous benefits to doing it through a DevSecOps fashion. Some people fear loss of control, like the security personnel. They may think, well, gee, if I'm not head of security, if the project teams are now doing security, I've lost control. I'm no longer, maybe it might be my job's not needed in cybersecurity. The reality is, yes, it is. You're still needed. The thing it really allows you to do is, as a cybersecurity personnel, you can focus on newer, more exciting challenges than the day-to-day operations. The project teams can handle that. You can work on investigating newer technologies, techniques, things that are more exciting. And project teams may push back also. They may say, well, why should I do your work? They may consider this the cybersecurity team's job. So they say, well, gee, you're asking me to do your work, your testing that you guys normally do in the cybersecurity team. The reality is it's actually going to save them time in release, from the time to where you conceptualize something to when it's released. So it actually will result in faster software releases. So yes, they're doing more because you're shifting left, but you're going to see significant advantages in delivery time. So the end result is they will see significant benefit. So if you look at the DevSecOps lifecycle, it's kind of an ongoing circle, like in some call it the infinity circle. Starts all the way with planning, to developing, then building, testing, and various things that we won't cover here individually, but all these individual phases. Testing, release, you deliver it and deploy it. Then you go into operations, do your monitoring, make sure that things are going well, and then get your feedback, and that kind of falls back into the next release. Well, what did you learn from this release? Is there anything you need to address? Etc. So you're implementing security tools at every stage of software development. You're helping identify vulnerable parts in your code beforehand and introducing the required security measures, and security monitoring. You're doing things like threat monitoring, network monitoring, and various things at the end. So not only security baked in, but also during operations. So security is not being added on at the end. It's integrated throughout the entire development lifecycle. So you're being proactive, and it really is a culture change, as we talked about before, because it's a newer way of doing things if you're not already leveraging DevSecOps. So if you take that view and sort of expand it linearly, sort of spread it out, if you will, you can kind of see the various gates become a little bit more clear. And you've got various gates of where you can have checks, if you will. How are we at build? How do we at development? How are we at test? And you're able to assess risk throughout the entire life cycle. And you got, various feedback loops to see how you're doing. So you're leveraging automation, and getting that continuous feedback. So automation is key within DevSecOps. What is done manually, you want to be automated as much as possible, and get that continuous feedback to understand where you're at security-wise, where your build's at. Did you have a failure due to maybe perhaps coding errors or perhaps security issues? You may want to actually fail a build if you have serious cybersecurity issues. If your tools that you're using to detect cybersecurity vulnerabilities indicate there's a serious vulnerability, you may want to actually prevent the build from occurring, forcing that shifting of left, if you will. So DevSecOps builds on Agile. So it doesn't replace it, it builds on it. So if you look at, what is Agile, you're favoring one thing over another. It's not saying another aspect is less important. You're favoring, for example, you're favoring individuals in the collaboration over the getting caught up on the processes and tools. Now, processes and tools, they're important, but it's those individuals and interactions working collaboratively together, exchange that information live, if you will, is the benefit. So it's more important to deliver software that works than comprehensive documentation. Again, we're not saying documentation isn't important. It is. But you want to focus on making sure your software meets the customer expectations. That's the focus. And work with the customer more collaboratively. Now, contract negotiation, that's important. But collaborating with the customer at each phase, at each release, working with them during evaluations, getting that feedback, that is more important. And today's world, you have to respond to change. Okay, yes, you need to have plans, but you need to be able to respond to that change. The only thing constant, as we've all heard, is change. So embrace it, as it provides the ability to increase value. So don't get frustrated at that customer request to change something. Look as an opportunity to delight the customer, and don't necessarily get hung up on following a plan. So in the DevSecOps handbook, they talk about the calming principle. It gives you, they call it calms. So if you look at it, the benefits of DevSecOps is, again, it's that culture shift. You're working from individual silos to collaboration. You're automating. So you're eliminating the work that you've done manually, invoking tools through automated processes that are not automated but repeatable and give you consistent results. And important thing is to constantly learn. You're going to fail. The failure is going to happen. Embrace that failure. It's not a bad thing. Now, if you repeat the same mistake 50 times, okay, you've got a problem, but embrace failure, learn from it. As our organization says, fail fast. If you don't fail fast, it means take risk, take logical risk. Eliminate waste. You're going to have failures. Learn from it. Embrace those failures and make the appropriate changes. In order to do that, you need to have measurements. You need to understand where you're at. So unless you have good measurement statistics and ways to measure metrics to understand your performance, how can you improve? So you have to have those metrics, and you continually adjust. Maybe you look at different metrics and make sure you're getting the metrics that are most beneficial to you and your business. And emphasis on sharing that information, share the lessons learned with one another. It's important to understand that everybody owns security. It's not just the security people. That we no longer we have silos. The way I put it is everybody is a cybersecurity engineer. Everybody needs to understand, at a minimum, the implications of not being cyber secure. So that's very important. So break down those silos, have development and operations work together, build that trust, foster collaboration, and you're going to find your work output improves because you're working together as a team rather than just throwing something over the wall, as I mentioned before. So what are some tools that you utilize in DevSecOps? Well, first and foremost, at the beginning is threat modeling. And I'm talking from a cybersecurity perspective. I'm emphasizing the security part of DevSecOps. Is you need to understand what could go wrong. What are the threats? How could attackers leverage potential vulnerabilities in your architecture? And based off of that, you derive cybersecurity requirements and an architecture, and then you follow that throughout. So after you've done that, you started doing coding. Well, you leverage static application security testing. It simply looks at your source code and looks for weaknesses. Is there any patterns in your code that a hacker could potentially use? Then you also look at your code as it's running, simulate attacks of your code at runtime. See, is there a vulnerability? Is your application susceptible to denial of service, etc.? And a newer type of technology is interactive application security testing, or IAST. It looks at vulnerabilities within your code. So you have an agent within your code. So it gets more insights into what's going on in your code while it is running. Now, an important thing I want to emphasize here, if these tools will not catch everything. Unfortunately, it's not a perfect world. You could have the best SaaS tool that's, everybody says this tool is the best. It's going to catch still only a fraction of all the potential vulnerabilities. As an example, if these tools were perfect, you would not be seeing monthly patches for your PC software, your mobile phones, etc. These major companies, if they can't get it perfect, you don't expect to get it perfect. These tools are not perfect. It's getting better, but these tools is very challenging to be able to examine code and analyze for vulnerability. So unfortunately, cybersecurity is going to be with us for the foreseeable future. Another important thing is software composition analysis, knowing what's in your software, building that SBOM or software bill of materials. So looking at what components you're using. A lot of times we're using open source software. Understanding what vulnerabilities are in the software that you have embedded in your code. So you're using, OpenSSL. Well, are there any current major vulnerabilities? And you need to look at that, address those vulnerabilities that could have an impact on your code. Another thing is fuzz testing. If you're not familiar with it, this is really a technique that attackers often use. It simulates an attack by simply throwing data that's invalid, crazy type of data at your system or function or whatever. It's either invalid, it could actually be malformed. And the attacker looks to see how your code responds or your system responds. And as a result, they can find vulnerabilities for buffer overflow vulnerabilities, where an attacker can leverage that, insert their code into your running system at runtime, and fuzz testing is a way to help catch that. And then, of course, we're deploying things in containers, so scanning containers and their components is also important. So if you look throughout the linear life cycle of the various activities that you would perform, You're doing things like, again, threat modeling, as we talked about, and deriving your security requirements. And as you develop, build, and test, you're leveraging these tools. You're leveraging IDE integrations with your tools, such as making sure your code doesn't have secrets or credentials hard coded in. That's a major no-no from a cybersecurity perspective. Using static analysis, software composition analysis at all phases, and making sure your developers have ongoing training for how do I write software in a secure manner. And then for sections of code that are critical, knowing these tools are not perfect, well, it's beneficial to actually have code reviews perhaps for critical sections of code. So as you traverse on, you're repeating many of these tests. And as you get going on, you're going to do additional types of tests like container scanning, fuzz testing of your application. And you can also do fuzz testing earlier as you develop. You could develop a function, fuzz test it, and it's better to actually do that shifting left. So as you're getting ready to release and deliver what you've developed, you make sure that your infrastructure is code, that you have secure configurations. You leverage an artifact repository. So if you have like containers, that you're pulling containers out of this repository, containers that have been vetted and have been analyzed for security and tested, and you know that they are valid. It's basically change management for compiled code, if you will, for containers. And now you're starting to do things like network security testing. So you deploy. Now you're doing IT type of security operations, operational security, perhaps doing pen testing. And then as you operate, it's also important to monitor what's happening out as it's deployed. We've all seen cases where systems were logging the fact that they were being breached, that attackers were getting in, but they didn't look at the logs. So you can log, but if you're not examining your logs to go, oh my goodness, I think we have a problem here, they're worthless. You're, looking at logs after the fact, it still needs to be done to understand, but looking at the logs as they're being generated to detect that you're being breached or you have been breached, that's important because that's some major fundamental flaws that have occurred in the real world. So as far as DevSecOps, talking about that shifting left philosophy of doing things earlier, normally you would do fuzz testing at the end. You would do your development, and also maybe a 8-week cycle. Then at the end, maybe you would do 5 days of fuzz testing, 8 hours a day, because you only had a week for testing. Well, now that you're doing DevSecOps, perhaps you're working 2 out of 3 shifts. This region of the world is developing code. This shift, this region of the world is developing code. This shift, then there's maybe 8 hours every night where nobody's writing code or developing. So you could leverage that, for example, and every night you could do 8 hours of fuzz testing. So if you look at it, you're able to do a significant amount of fuzz testing, much more than doing it all at the end, leveraging that time. So you've actually gained a week of development time because you've been doing that fuzz testing and the other testing throughout the life cycle. So that's very important. All right, so let's summarize what are DevSecOps best practices. So first thing I want to emphasize, training, and more training. You don't want to have just initial training. You need to have ongoing training. I recommend secure coding labs. There's solutions out there that, okay, the developer's taken training on how to write secure code. Well, that's great. But I don't know, at least me, if I had a class 3 years ago, I may not remember all of it 3 years later. I need continuous reminders. So there's classes to have short little labs, if you will, hands-on labs, for example, to remind you of these techniques to where it's actually hands-on. So it's like find the cybersecurity flaw and fix it. So it's not only just sitting there, listen. I remember in college, I would listen to a lecture and I would think I understood the lecture, go to do the homework and find out, no, I guess I don't understand it, because when I went to apply it, what I thought was understanding, it was more acknowledgement, not really understanding the material. So having those hands-on labs can be beneficial. It's also important to know what's out there. Have an app inventory and a risk ranking. So if you have apps deployed, have a risk ranking. So if and when there's an issue, you can quickly assess, maybe you've got a couple apps and you've got issues in a couple apps. This will help prioritize development. You know what your risk ranking is. Know how many customers could potentially be affected by an issue. And important metrics. You need to collect those metrics, analyze those metrics, and adjust, based on, learn something. Don't just collect it, look at it, go, okay, well, gee, because of that, we're seeing this, we need to tweak this, adjust this, and you repeat that, collect metrics, analyze, adjust. And we talked about failing early, that you do want to have frequent and security and feedback gates. So have those gates earlier. You don't want to wait to the end. That's what DevSecOps is all about. Those many individual small gates throughout. So fail fast. Check your code with software composition analysis, with static analysis. Check it and fail fast. Make those corrections. And the play on words here, hesitancy to commit. Well, basically, it's simply what I'm saying is check your code before you put it into a repository. Make sure there's no vulnerabilities. Check for secrets. Are you hard coding secrets? And one of the advantages here is if you detect a vulnerability while the developer is in the code or it's fresh in his mind, it's going to be a lot easier to fix that code before the developer task switch. So the developer is going to go on to something different, a different project, a different section of code. And if they're in that new section of code for days, or could be hours, and they're starting to develop code, now you tell them about a defect in code that they developed a day ago or a week ago or a month ago. It's going to take them a while to get back up to speed to understand what the code is doing, the implications of the bug. For example, the way I kind of like to illustrate this is if you're writing a book and you've got 20 different characters in various states in that book. This character is at this state in their life and they're doing this, and this character is doing this. And then you walk away from that book. You're writing that book and you go on vacation for a week. Then you come back and now you need to resume writing additional chapters. It's going to take you a while to think, okay, well, Joe in this book was doing this. Fred was doing this. It's going to take you a while to get back up to speed. The same concept applies, that before the developer moves on, if you can catch those flaws, he's able to fix them, or they are able to fix these flaws much more quickly. You want to customize your SaaS program. As you're doing these SaaS scans, leverage incremental scans so you're not doing a complete scan of the code to get that frequent and fast feedback. Make sure that your filters you're applying are the right filters for your organization. Certain rule sets may apply better in your particular type of architecture, your type of software, etc. Making sure you're using those filters intelligently and applying the right filters. And making sure your infrastructure is secure, that you want to have ongoing scans for vulnerabilities. Leverage the tools in your cloud provider. They provide the ability to monitor your security posture of your cloud, and you'll see your security posture. If you do nothing, it will continually lower because they're finding new ways to assess vulnerabilities in your cloud infrastructure, and so it's actually an ongoing task to make further improvements in your infrastructure. So having that ongoing monitoring, leveraging infrastructure code, scanning your containers, etc., is very important. And use those repositories, artifactories that are used to, say, if you're going to have a container, that after that container has and the software within has been fully tested and vetted and approved, Artifactor is a way to formally sign off on that. Yes, this container can be used. And when you're pulling that container out to deploy in production, you know that you have those packages are authorized, approved, and it actually eases deployment. And again, test, and test. You cannot emphasize that enough. Don't wait. Test early, test often, shift left, and it will help assure success. So that being said, I want to thank you for your attention. It was a great opportunity to be able to present on DevSecOps, and I am very much looking forward to your questions as we've seen what DevSecOps is, how it can benefit you, and we talked about best practices. So I'm looking forward to your questions. Does anyone have any question?